Hello everyone. Today, I just want to make a brief summary of area under the curve. Alright, so to begin with, I'll give the meaning of area under the curve first so that we can understand it. Okay, so we already did integration. Give me the pen. We already did integration f of x with respect to x. So it was giving us a function plus c. So in integration, we do everything, but at the end we write c, where c is arbitrary constant. But in area under the curve, we have to find the value of c. That's the only difference. So it is also called this one. It ends up giving you a number area. It ends giving an area or a number. That's the main difference between this one and the previous integration. So for us to find c, we need two values of x in our case. So two values of x, one will be on top, so the one on top will be x2, the one down will be x1. You're going to have the f prime of x, or the derivative of function, with respect to x. At the end, we're going to have these two functions, f using x2 minus f using x1. So you subtract them. First you find the function, then later you use x2 minus f of x1 at the end, after finding the function. So we can draw this one using a graph, just to come up with what we are saying. So we can have a function like this. So we can have here as x1, here as x2. So this one is f of x. What we need is to find the area that is enclosed this area. How much is it in units? So no area is in square meters, square centimeters, square inch, depending on the unit you are using. Okay, let's continue. What else should we know? No, there's no way. Alright, let's continue. So after having this understanding, we can see on an example. Example. Find. Okay, let me use this pen. Let's remove this. Let me use this pen. Find. Here have 2, here have 1, and f of x is x. What is this dot doing? X. Let's put okay. Let me put 2x plus 3. So they want us to find that one with respect to x at the end. Don't forget that. So for us to solve this one, first we find the integration. So the integration of 2x plus 3 with respect to x, it will be 2. See, x is power 1. We increase the power by 1. So 1 plus 1 will be 2. Divided by the new power. The new power is 2 plus 3x. Here the new power is 1. So divided by 1 used to be the same thing. So plus c. This one is before introducing the constants for this side and the one for this side. Right? Let me go back a little bit. Yeah, just to remove those values. Alright. Our work is to find the value of c. Then, using the limits, so we have two limits there. If you see clearly, we have two limits. Let me avoid that. So these two limits, we have 1 and we have 2. Alright. 1 and 2, those two limits. Let me go back a little bit, removing those cycles. Alright, our function is already there. Let me change the color of the pen. Okay. 2x plus 3. We already found this one to be I forget to cancel 2 and 2 at the end. We have x squared so we have x squared plus 3x. So you put this line, like you put the upper limit on top 2 and that one down. It means there's a difference between them. Finding earlier, it means there's a difference between those two values. The first at the end, not first, at the end, you just put where there's x, you put 2. So we have to write f of x2 minus f of x1. So f of x2, just take this function that you have here. Take this function that you have here and substitute it where there's 2. So you're going to have 2 squared plus 3 times 2 minus. So put them in the big brackets, such that you start with you do brackets separated. The same function, but now x is 1. So at the end you subtract those brackets. So I have 2 squared is 4 minus 3 times 2 is 6 minus 1 squared. 1 squared is 1. 3 times 1 is 3. That is plus here. Yeah. Alright, at the end we're going to have 4 minus 6. 4 minus 6. The answer is minus 2. Minus. Oh, this plus, not minus. Oh, ma. I forget that. So 4 plus 6, the answer is 10. 10 minus. Let's put it bracket, there's no problem. 1 plus 3, the answer is 4. So half 10 minus 4, the answer is 6. Equal sign. Don't forget those equal signs, they are very important. So this is the answer. So you put units because it's area, units is square. No problem. So if you do that, it means you're an expert in these ones. Right, let's see another example. Find the derivative of which example should we use? Because I'm just trying to put things together. Let me see the one that you have in your examples from your class. So from your class, okay, so from your class you had this example which says let me see clearly. Alright, so they do not start like that. How they started, it's like this. So this one is example number 2. Example number 2. For me, I'll put it like that. They're saying calculate the area bounded by the curve. The area bounded by the curve y is equal to x squared plus 2x. The line or the limit, x is equal to 1 and x is equal to 5. So if you see there, we have two numbers, x is equal to 1 and the other one is x is equal to 5. So we have two. One number is bigger and another number is smaller. So the one that is bigger will be the upper limit and the one that is small will be the lower limit. So you're going to have upper limit is 5, lower limit is 1. F of x is x squared plus 2x dx. So we'll go straight to the derivatives. The integration. So I have x squared, so it will be x power 3 divided by 3, new power is 3, plus 2x it is power 1. If we add 1, it will be 2, divided by the new power is 2. Then the upper limit is 5, the lower limit is 1. 2 by 2 will cancel. Let me change the color. 2 and 2 will cancel. Then After that, cancellation, we're going to have the black x power 3 divided by 3 plus x square. Upper limit is 5, lower limit is 1. So simplifying this one, have two brackets. X now is 5, so it'll be 5 power 3 divided by 3 plus x is 5 power 2 divided by, no, there's no division for that one because there's no fraction in that number, minus here x is power 1, so it'll be 1 power 3 divided by 3 plus 1 square, it will still be 1. Okay, let's continue with that one. So let's bring our calculator here to make sure that everything is going on smoothly and we're not making mistakes. So I brought my calculator like that one. Let me make this one smaller. So in this calculator, you're going to we'll just put everything on the calculator, by the way, to make things easy and simple. So we start with the brackets, then we have fractions, right? So in this fraction we have 5, then that 5 is power 3, so 5 power 3 divided by 3, then there is plus 5 square, 5 power 2, close bracket. So you see that? Then we're done with the first bracket, go to the next bracket. So there's minus the same contents. So but here there we have 1 power 3. Okay, fraction first. 1 power 3 divided by 3 plus 1 square, close bracket. So you're going to see that the answer is 65.3. 65.3 if you're using the calculator. So at the end, you're going to have 65.333. So this is the area that we are looking for in that example. So this is our answer. We can minimize the calculator and underline the answer. So I forget to put this one, unit square. So that's it on an example. So we are done with that one. Oh, all right, I forget something. Let me just check quickly. What did I forget? Yeah, there's nothing that I forget. So at the end, we have to do this using a calculator. In case if you just have a calculator, what are you going to do? So there are two ways. This calculator is only used to check the answers. The calculator is only used to check the answers. So let's go to the first one. The first one, we say, the first example, we said, find the derivative of 2x plus, the integration of 2x plus 3. The upper limit is 2 and the lower limit is 1. X is equal to 2, x is equal to 1. 2x plus 3.